Look at it from the front, and your brain refuses to process what it's seeing. Two separate fuselages, two separate cockpits, though only one is ever occupied. 6 engines, taken from a retired 747, mounted across a single wing that connects the two hulls together. A wingspan of 117 meters, wider than a football field, wider than anything else that has ever taken off from a runway. It looks like someone took 2 airplanes and welded them together at the wing, because that is essentially exactly what it is. This is the Stratolaunch. And unlike almost every other aircraft, it was never built to carry cargo, passengers, or freight of any kind. It was built to carry something that needed to start its journey moving at high altitude and high speed: a rocket. Dropped from beneath the wing at 35,000 feet, its engines igniting only after it has already left the aircraft behind. The idea itself is not new. Rockets have been air-launched from beneath aircraft since the 1940s. And companies like Orbital Sciences had been doing it commercially for decades using conventional planes. What made the Stratolaunch different was scale. The ambition to air-launch rockets large enough to carry meaningful payloads to orbit, which meant building an aircraft large enough to carry a rocket that size in the first place. The person who decided to build that aircraft did not live to see it fly. Paul Allen co-founded Microsoft with Bill Gates in 1975. By the 2010s, he was one of the wealthiest people in the world. He was one of a small number of billionaires personally funding private space ventures, a direct expression of a lifelong fascination with aviation and spaceflight. Allen had already backed Spaceship One, the first privately funded aircraft to reach space in 2004. Stratolaunch Systems, founded in 2011, was his next and far more ambitious bet: build an aircraft capable of air-launching orbital-class rockets. This offered a launch method that didn't require a fixed launch pad and could operate from conventional runways. It could reach a wide range of orbital inclinations simply by flying to the right position before releasing its payload. The engineering challenge was not the rocket. It was the aircraft that had to carry it. An orbital rocket, even a relatively small one, weighs far more than any cargo an existing aircraft could carry externally. Stratolaunch's engineers, led by Burt Rutan's Scaled Composites, concluded no single fuselage design could provide the necessary structural strength and stability. Their solution was the twin fuselage configuration: 2 separate hulls connected by a single wing structure strong enough to carry a rocket slung beneath. The weight and aerodynamic loads are distributed across both fuselages, rather than concentrated in one. It was the opposite engineering philosophy from the An-225. The Mariah solved its problem by building one enormous, conventionally shaped aircraft. The Stratolaunch solved its problem by building something that had never been shaped like an airplane before, at all. The Stratolaunch's construction began in earnest in 2011, at the Mojave Air and Spaceport in California, a facility that has hosted more experimental and record-breaking aircraft than almost anywhere else on Earth. The aircraft's structure presented problems that conventional aircraft engineering had never needed to solve. A normal airplane wing carries the weight of the fuselage and fuel, all loads that are relatively evenly distributed or centered. The Stratolaunch's wing needed to carry 2 full fuselages, while supporting a rocket suspended from the center section between them. The wing itself became the aircraft's defining structural achievement. At 117 meters, it needed to resist immense bending and torsional loads. Scaled Composites built the wing using advanced composite materials, rather than traditional aluminum construction. This approach is used in modern airliners like the Boeing 787, but pushed to a scale no composite wing had previously attempted. The propulsion system used 6 Pratt & Whitney PW4056 engines, sourced from retired Boeing 747-400 airliners. This cost-saving decision also meant the engines came with decades of proven reliability data already attached to them. 6 engines were necessary to get an aircraft with a maximum takeoff weight exceeding 500,000 kilograms off the ground. The landing gear needed 28 wheels across the 2 fuselages, distributing the aircraft's weight to avoid runway damage. Paul Allen died in October 2018. The Stratolaunch had not yet flown. The aircraft he spent a decade building sat on the ground at Mojave, its first flight still months away. Its founder gone before he ever saw it leave the runway. The Stratolaunch made its first flight on the 13th of April, 2019, roughly 6 months after Paul Allen's death. It flew for approximately 2.5 hours, reaching an altitude of around 17,000 feet, without any rocket attached. The flight confirmed what the engineering had promised. An aircraft with the largest wingspan ever built could actually fly, stably and controllably, despite a shape that looked to most observers like it shouldn't be able to. But the company Allen had founded to operate it did not survive much longer in its original form. Following his death, Stratolaunch Systems was sold, and its new ownership shifted the aircraft's mission. Rather than developing and launching its own orbital rockets, the Stratolaunch would instead serve as a launch platform for other companies' hypersonic test vehicles, a change in business model that kept the aircraft flying, but redirected its purpose away from the orbital launch ambitions. Under this new direction, the Stratolaunch has conducted a series of captive carry and air launch tests, carrying hypersonic test vehicles developed for both commercial and U.S. military research purposes. In 2023 and beyond, the aircraft has successfully released hypersonic test vehicles in flight, proving out the air launch concept, even if the specific vehicles being launched are no longer the orbital rockets Paul Allen originally envisioned. This is the part of the Stratolaunch's story that rarely gets told alongside the record-breaking Wingspan. The aircraft that was built for one specific, ambitious purpose, putting satellites into orbit without a launch pad, never actually did that job. Its founder died before it flew. Its original company didn't survive to complete the mission it was built for, and yet the aircraft itself kept flying, repurposed for a different but related task. Because the fundamental engineering achievement remained valuable even after the specific plan for using it had changed entirely. The Stratolaunch holds the record for the largest wingspan of any aircraft to ever fly, 117 meters, exceeding the AN-225's roughly 88 meters by a wide margin, exceeding every airliner, every military transport, everything else. It is, by that specific measurement, the largest flying machine humanity has built. And yet it remains, even now, one of the least publicly recognized aircraft of its scale. It has flown a fraction of the missions the AN-225 flew in a single year. It has never carried its original cargo. Its most famous moment, its first flight in 2019, happened without the rocket that justified its existence. There is a specific kind of engineering story that the Stratolaunch tells, one that is different from every other machine. Most of the vessels we have covered were built for a purpose, and then they performed that purpose exactly as intended. The Stratolaunch was built for a purpose its founder did not live to see fulfilled, by a company that changed form. It is carrying out a mission today that is related to, but distinct from, the one that justified building it. It is a reminder that engineering achievement and commercial success are not the same thing. The Wingspan is a genuine engineering triumph, a structural and aerodynamic solution to a problem no aircraft had solved before. But the space company built around it redirected before its founder's original vision was ever realized. The aircraft still flies. Its wingspan is still the largest in the world. Somewhere over the Mojave Desert, it still climbs. On test days, it carries a hypersonic vehicle beneath its center wing, preparing to release something that will ignite in midair. This is close to the fundamental idea that the sky itself could be the launch pad if you built something large enough. That is the Stratolaunch, the widest wingspan ever built, a mission that changed before the aircraft ever proved itself, and a billionaire's dream that outlived the man who dreamed it, even if it never quite became what he set out to build.